So is my screen visible?
Yes, it is. The Iowa data science screen, right?
Yes.
Okay.
So last time in our presentation, we saw introduction to NLP and introduced some little bit about machine translation. And towards the end on the presentation on the machine translation modeling, I talked about transformers as being the recent state of the art. Not even recent, it has been like quite a while, since about 2018-19. It started 2017, but subsequently dominated all the areas in NLP, in AI, and the rest. So transformers. So today what we are going to see is just to have a feeling on how to generate translation yourself. What you've been maybe observing or what you have experience on is how do I take a text, open Google, search for translate application, and then put in my text, and then the text gets translated. But how is everything going like under the hood? How do they do those translation that you are given? So it's just straightforward. What you need is the compute that is strong enough to train your model if you require training, or if you have a model that is already trained, how to use that model to generate translations. Most of the codes that you may use towards this endeavor is already available online, most of it. So we leverage the presence of code bases, either through Hugging Face or through various GitHub repositories that are made available that implement such codes that is just plug and play. You give it your own data, or if you are doing some form of research, you can modify those code bases to suit your own hypothesis, your own experiment sets, and the rest. So this notebook that is prepared, I prepared it last year and made a presentation at the Deep Learning Endeavor. So, and I thought it will be useful if I just readopt it and present it here. You will see a lot of codes, but most of those codes we will not even explain them, because what you are doing is machine learning for beginners. You are not going into deep learning research. So you will see the code, they are just meant to be run. If you want to use the notebook, what I will show you now is just how to run from the beginning to the end until either you finish training your own model or you finish generating translations, whatever sort of translations you want to generate. There are codes that we hide. We will expand them to see them, but the essence of hiding is so that the notebook will not look bulky. There are also some forms that are added such that you don't need to be interacting directly with the code, but just with you design, let's say, a web page, and you want a user to sign in. You don't intend, or you don't want the user to be supplying his credentials inside the code. What you present the user with is just a form that you ask him, put in your password and put in your username, and then a button to click and the rest. So some of those forms are added here so that you just give in the text you want translation for. And under the hood on that code, there are under that form, there are some code implementations that take whatever you are given as input and then generating the translations if we come to that step. And we will see that code also. So we'll be seeing all top level presentation of these codes that we can just run, but we can also expand the code to inspect what is happening under the hood. So leveraging pre-trained models for improved low resource machine translation. So as we said, part of the challenges of natural language processing, and especially machine translation, is the lack of adequate qualitative data. So sometimes you might have a lot of data that are not qualitative. Sometimes you might have just a few qualitative data that are not enough. So in this instance, there are various methods that you follow to improve the performance of low resource machine translation. What I did my PhD in is to investigate this low resource methods and to try to propose some new methodologies that will improve the performance. And I'm working presently with some research students also working along this line for improving low resource machine translation. But a method that has been shown to work quite well is taking a pre-trained language model. So if we say pre-trained language model, I think I have a transformer here. Are you seeing this Hugging Face page?
Yes.
Hello? So I think let's click on. So if you go into Hugging Face, you will see that there are a lot of models here that are already pre-trained. So what you need, and most of these models are pre-trained to do some specific task, but not very well. So the next step, if you want it to work well on your own task, is to get some examples that are related to your own task, and we do the process called fine-tuning. So the model is pre-trained on a large number of data sets, and before deployment, you are expected to fine-tune the model so that it works well for you. So these are examples of models. You see GP22, but based on case, M2M, as we saw here, the Bata, Robata, whatever, but based multilingual on case. So these are different types of models that were trained either using different quantities of data sets or even using different architectures. That if you want to dive into these architectures, there are the papers. So if we look at this XLM Robata, you will see that XLM Robata model was pre-trained on 2.5 terabyte of filtered common crawl data containing 100 languages. So you see it was introduced in the paper. So you can read the paper, you can go into this repository to find more about it. So you see it was pre-trained on 2.5 terabytes of data. I think even your computer might not even have the space to take the data, talk less of training the model. So these are especially large models that are pre-trained for you to be used by the community. And what Hugging Face do, fortunately for us researchers, is to provide a platform in which all of these models are available to us. So that if you want to use a particular architecture, you don't need to start training the model from the scratch because you don't have the computer, you don't have the storage, you don't have the money to buy it. So the model is pre-trained for you and kept there. If you want to use it, you just call it and it will work for you. So calling it in here, what we are doing is to do the fine-tuning. And what do we mean by fine-tuning? It's now, as an example that I usually give, there was an example that is also very common, that is given especially in transfer learning. A model was trained to recognize the faces of individuals. So after the model was deployed, it was found out that if you give it the face of a Black person, it will classify that person as monkey because it doesn't know that that person is even a human being. So it was later found out from the data set that there was no representation of Black people in the data set. So the model was not said, no, let's throw away this model and start training from the scratch. The only thing they did was to get another sample of faces, smaller sample usually of faces that are of Black people, and then do the fine tuning on the model so that the model will increase in its knowledge. So this is what we call fine tuning. So now let's say you take a language or a data set on Wikipedia, and Wikipedia contains a lot of data, and you train a model. So that model might be called a generic model. If you want to use it, let's say to do translation in in, let's say, computer science, translation in computer science. So you see in computer science, there are some technicalities that might not be available in that generic model that was trained. So doing fine tuning is getting small data that is related to computer science and then fine tuning the model so that the model will now say, yeah, now I know computer science, so I will be very good also in computer science, rather than maybe at the first instance, it doesn't know what those terms are. So we did a paper called A Few Thousand Translations Go a Long Way, leveraging pre-trained models for African news translation. So during the implementation of this paper, some data sets were created covering many African languages, including Hausa, Igbo, and Yoruba. So that data set was released for the research community to use. And we tried to show how well a pre-trained language model can perform if given even few thousand translations. If you compare few thousand translation, as we will see here in the Hausa data set that we'll be working with today, it consists of 5,000 plus parallel sentences. So I think the present state of the art translation in English to German was trained on about 200, I think, and 30 million sentences, 230 million sentences. But here we only have 5,000 sentences. So imagine the performance between these two. The first one can even be trained from the scratch and you will get a decent performance. But if you train this from the scratch on 5,000 sentences, it will be giving you a lot of errors or a lot of mistranslations because the data set is not enough. So in this tutorial, we'll be learning and practicing also the use of pre-trained language models to train a machine translation model. This notebook was designed to train a machine translation model by fine-tuning pre-trained language model on few thousand sentences. And the notebook supports M2M 100, MBAT 50, MT5, and Byte 5. These are architectures that are all present in Hugging Face. So if you go to Hugging Face, here you can search Byte T5, and you will see Byte T5 here. It's a Google pre-trained language model. It's already here. You can search, say, M2M 100 is released by Facebook. So you see all of these large companies have already done the pre-training for you. What you just do is to take the model pre-trained as it is, and then utilize it in your own downstream tasks. So the content is just low resource machine translation, and the level that is required to the level of expertise that is required to train this model is just a beginner or an intermediate. You don't need to be an expert to run this. So far as you will just stick to the instructions that are given, you are fine. You don't need any help to run this notebook. If you want to become an expert, start reading, knowing about Python in depth. Read all of these code bases before even saying, let me change this code or let me change that code, because by that point you may have known all of the codes, what they are meant for. So what you are expected to learn, the aim is to set up a training pipeline for fine-tuning a pre-trained language model for MT. And your prerequisite is using Colab. The essence of using Colab here is we are relying model prediction, or we call it inference sometimes, prediction, relies on GPU, but also especially training a model relies on a GPU. If you are training a model on a CPU, it might take something that will take, let's say, 1 hour here might take you 1 week or 2 weeks to finish on a CPU. So, and most of our computers, and some of us are even using phones to do some of these experiments, do not have the required GPU to run this. So Colab here gives you a platform for running this type of experiments on the cloud without you requiring to buy any GPU. There are 3 types of Colab instances. You have first the free, second the paid, but even the paid are 2. you have Colab Pro, and then you have Colab Pro Plus. All of those have their own features that you might Google to see the difference. But on a Colab free, you can run your basic experiment with the GPU that is available. So before you start running, after you open this notebook, let's say you have this notebook, before you start running, what you are expected to do is click on runtime. If you look at the menu bar here, there is file, edit, view, insert, runtime. So you click on runtime. So when you click on runtime, you will see something called change runtime type. So if you click on it also, you will see that there are different types of runtime. You see Python 3 and R. If you are working on R, you can put in R. If you are running, it's just like selecting kernel on what's it called, on your VS Code. So the hardware accelerator, if you see that there is none, if you put in none, it means you are using CPU. If you put in GPU, it means you are using GPU as the name is there. Then there is also TPU, which is tensor processing unit. But most especially, you are expected to select the GPU. If you have paid Colab, you will see all of this option, T4, A100, V100. They are listed in decreasing order or in increasing order of capacity. So the first one is T4, which is available free. If you have paid Colab, you can select either A100 or V100. The type of GPU that you select will determine how fast your performance or your model training will be. How fast, but also how big you can train. What we are training here is just a small, I think 418 million parameter model, but there are models that are in billions of parameters. So in those models, you will see that they are very large. Even the GPU, you need a very big GPU to support them in the memory. So, but the model we are training now is something very simple. And also we'll not go into the training, and I will explain to you why we'll not go into the training, but I will show you, if you have your time, you can run the training by yourself without requiring any help. But these are the settings that you are expected to follow. Select your run type as Python, select the hardware accelerator as GPU, select its type. If you have the paid one, you can select A100 or V100, but if you don't have, it's automatically set to T4, which is the smallest GPU version. So the next thing to do is to connect. So in this case, Colab, you can click on this folder. If you open this notebook, this tab is minimized already on, because I connected before, so that's why it's telling me, do you want to reconnect? If you open it, the first instance, it will show you either connect here. Below this share button, you will see a connect, or you just click on this folder. There's a folder here at the left panel. So if you click on it, you will see that it starts allocating, connecting. You'll see the status is changing. So, and when it finishes connecting, it start initializing, and then I think that will be all. It's connected now. So you can view your RAM, your GPU, and your disk. You see this have a RAM of 12.7, a GPU RAM, which is not specified here, but you have your disk that is available freely for you as 78.2. In that 78.2, 24.1 have already been utilized and it's in use. So you don't need this. I just want to demonstrate. That's why I opened. So you don't need this. So the next thing you want to do is you want to mount your Google Drive. We can run this model on the Colab disk that was provided. But if anything happened with your session, or your internet finish, or NEPA take off light or whatever, all the files that you save will be lost. But if you mount your Google Drive, all the file that will be saved inside your Google Drive, so that even if at the end of the day you have any glitch with either your network or your computer or your power or whatsoever, files that have already been saved will be inside your drive, And when you want to continue running or you want to do some sort of experiments, whenever you open Colab and you remount your drive, your file will be there without you having to create them from the scratch again. So as I said here, we've hide some codes, but we can open this code. So to open the code, you just click on show code, and show code will tell you that here, this code from here to here is taking care of mounting your drive. After you mount your drive, you want to go into the drive. So you change directory into the drive so that whatever you are saving will be saved inside the drive. Importing OS to determine whether this directory, which is called Arewa DSMT, which will be our folder that will be saving everything that we are working on machine translation. So this folder, if it is available, then that's it. If it is not available, this code will create it for you. So, and after creating or after checking whether it is available, it will change directory into the folder. So you don't need to open this code also. I said we will be open if we will open if there is need for that. So you can hide the code after inspecting. So what you need to do here is you just run this code. So at the first instance, Colab will warn you that do you want to permit this to have access to your Google Drive? You tell it connect to Google Drive, meaning yes, you want it to have access to your Google Drive. You select the account, and the account that you are running Colab, if you look at here, near this, I think, are you seeing my mouse pointer?
Yes, sir.
Okay, so if you look at this account, is the same account that will be listed here. Earlier, you can select any Google Drive to work with any Colab notebook, but now you can only use Google Drive that is associated with that Colab notebook. So if the Colab notebook, let's say, is hausanlp@gmail.com, you will see the email address listed here will be hausanlp@gmail.com. So it will be only one drive, Google Drive. So you select it, it will ask you, do you want to give permission? You tell it allow. So, and that's it here. So, and you will see after mounting, you just wait a little bit for the code to finish running. After mounting, it will go into your new folder that you want to. So you see, it has mounted it at content/drive. It has changed the directory into my drive, and also it has changed the directory into Arewa Data Science empty. So this is the folder that we will be working on. So if you refresh these files, if you refresh, you will see there is the drive. Now your drive, Google Drive, has been mounted. So this is your Google Drive that is attached to your email address usually. So if you click on it, it will be expanding, and you will find all of your folders that are inside your Google Drive. So this is this. If let's say I open this. So you see all of these folders that are here, 52.txt, Arewa Data Science empty. Look at this. This is the new folder that we just created while running the code. So all of this, if you check here, you will find 52.txt, Arewa Data, DSMT, and the rest. So these are here. And already you have changed your directory into Arewa Data Science empty, which is now whatever you are doing will be saved into this folder, which is called Arewa Data Science empty. So the next thing you want to do is to clone the Mafand empty GitHub repo. The Mafand empty GitHub repo is the repository for this project that I explained before. So, and why we are cloning it is because the data set that we'll be using is inside this repo. So you clone it. And how do you clone? We can show the code. The cloning is just git clone, which you've already are familiar with. And this is the URL of the repository. So we clone it, and this is it. So we can also hide this form, this code, sorry. So I've already run this and it is cloned. And if we look at it in here, you will see that there is Lafand empty, which is this repository is already cloned. So now we'll install all the libraries that are required to run this model. We can also expand this to see these libraries. We can say show code. So the libraries include touch, transformers, dataset, sentence base, Sacre Blue, Accelerate. And all of this, you may know their usefulness. So transformer gives us access to all these models that are on Hugging Face. Data sets enable us to play along with data set. Sentence piece here is for tokenization. And I think in introduction to NLP, you have already read about tokenization. Then Sacre Blue is the metric that is used to evaluate the performance of translation models. Then Accelerate is just a library that make your running to be faster. So we can hide this code also. So these are just the basics that you do. After running this code, this cell, you will see all of this running, meaning it is installing, collecting transformer, collecting data set, collecting sentence space, collecting Sacre Blue, collecting Accelerate. So after it got all this, it will install them for you. So then afterwards, you import all the libraries that you need. So most of the libraries that you've been working on, you say import pandas as PD, import numpy, import sklearn, import whatever. So here, this you import OS, data sets, transformers. So because we do this, I think let's install the required files. Here, I think let me put in capture so that all of this code will not be disturbing us. Before, all of this capture are just available on the paid version, but I think now it's also available on the free version. So you can run this. So the essence of that capture is so that it will not be showing us all that, collect this, install this, but maybe because you are running this as a starter, let's show the output. So let's comment capture out and then hide the code. If we run this, you will see that it is collecting all of this. Whatever is available, you will see that it's already satisfied. If the library that is expected to be installed is there. If it is not there, you will see that it's collecting. And afterwards, it will tell you that it is installing. So installing collected packages, and then this is done, successfully installed. So you finish installing. So before on this data set, you will be seeing some lines. It is telling you that data set has not been installed. Transformers too will have some lines, meaning transformer has not been installed. So what you do here is after you finish installing, you will see the lines disappear, meaning you have installed everything. So you see here, you don't need to do anything. What you need to do is you run this code. Running this code will import all of the libraries that you need for training, for generating translation, and the rest. So we also hide this code because we don't need to make any change. You just run the cell. So after running, so now you've import all the libraries that are expected to run your model. So the next is setting up the training module. So the training module is a lot of code. We hide them, but we can show them here. So this is the code or the function to start the training. These are log levels and whatever. These are data set reading, the training data, the validation data, the test set. You are reading them. These are setting some configuration with the tokenization, with loading the pre-trained model that is in transformer. These are whatever. So if you look at it, pre-process function for the data set, training, data collator, the metric, which is for evaluation. So these are a lot of code. That's why I said, if you are not going deep into machine translation, you don't have anything to do with the code. What we just put them here is for you to be able to train your model. So training the model, and if you become an expert, maybe you can inspect them to see whether there are something that you can contribute. But the next thing to do after importing your necessary library is to run this too. So you run it. So after running, you see it has defined the training model for you. So these are the data and model argument classes. Also you run, you don't need to make any change to it. These are getting your arguments. So getting all of the arguments that you are passing to the model trainer. So you run it again. So now this is actually where you pass in your training parameters. So training parameters include the output directory where you want your model to be saved after training. So let's call this one 2 because I've already trained one. So the model name or model path is called Facebook/M2M418. And I think I showed you, you see Facebook/M2M100 underscore 418 million parameters. So this is the same model here that you are using. Look at, this is the same model that you are using, M2M100. So you need to pass in a model that is available on Hugging Face, or if you have it already in your what's called in your Google Drive, you can just pass in the folder that the model is available inside. You just pass it. So the training file, you pass in where your training file is, where your development. So development is also known as validation. And I think you know what that means with your experience in training machine learning. And this is the testing. So the development is meant to be evaluating your model when it is training to determine whether is this model training or is it not training. Then the testing is when the model finished training, it will evaluate its performance after training to determine the model, how well will it work on a data that is never seen during the training. So we've trained a model that will do translation from English to Hausa. So this is the source language, and then the target language is Hausa. The maximum source and the target length, it means how long do you want your English and Hausa sentence to be. You can set whatever number, but 228 is a decent number. So number of training epochs, meaning how many training epochs, how long will your training last? What we mean by epoch is training all over the, so for one epoch, you train all over the number of data sets that you have. So this is what we call one epoch. So for 3 epoch, it train over the number of data sets that you have 3 times. So this is 3 epochs. So per device train batch size, meaning how many sentences will you be taking per training? So we'll be training on 4 sentences at each training step. So number of beams. Beam is a parameter that determines during, so when you are doing training, the training takes sentence and try to predict what is the best translation. So, and it works from, let's say, not let's say, but it works from left to right. So if you are working on, let's say, I am a good person. So it starts from I, then good, then no, I, then am, then a, then good, then person. So it will be encoding this what as it goes through the sentence. So this number of beam is, if it is, let's say at I, what is the next word that is expected to be generated? So usually there is a decoding strategy called greedy decoding, in which at each time step, if you have I, the next word that will be predicted is only one word. The next step is only one word. The next step is only one word. And at the end of the day, maybe after I, the best word to generate, let's say, is am. But then maybe the next word to generate, the best word might not be am, it might be another word. So you might be saying, yeah, at each time step, let me take, this is the best word to generate. This is the best word. This is the best word. This is the best word. Maybe at the end of your sentence, you will see that what you've generated doesn't make much sense, because a sentence do not supposed to be relying on which word am I considering. So if I consider I, then at the next time step, I'm only considering am. Then maybe at the next time step, I'm considering only a. So what this beam does is, instead of predicting or generating the best word, you generate the best 5 words. So if you have I, it will predict that there is am, there is I, then there is was, then there is and, I and. So it will say, yeah, these are the best 5 words that are supposed to be generated. So, and when it goes to the next time step, it will start saying I am, and it generates the next one. Then I was, then it generates the next one. Then I and it generates the next one. So then after then it will select from those best 5 which one is the highest in terms of performance, or which one makes the most sense. So it will take only that one, and then it will generate the next 5 sentences. So this beam means instead of generating only the best next word, you generate the best 5 words instead. So maybe you understand this, but if you look at it into literature, you will know what it means. So saving steps, meaning at the end of every 5,000 steps, you save a checkpoint. So why we do saving is sometimes if you are working on this and you don't save, something might happen, and then maybe your network get cut off, or your computer's charge finish, or whatever, and then you have to start training from the beginning. But if you save, the next one, it will start from this model that you saved instead of starting from the beginning. So after every 10,000 steps, it will save a checkpoint, if you understand what I mean. So 10,000 save a checkpoint, 20,000 it will save another checkpoint, 30,000 it will save another checkpoint, meaning it will be replacing that checkpoint with, if it evaluates this checkpoint and see that it is better than the checkpoint that I have saved already, then it will replace it. If it is not better, then it will not replace it. So it will be replacing with the next best. But some architectures save 2 models. The first model it's safe is called the best checkpoint. The second model it's safe is the model that is at that checkpoint. So you will see 2 models. One is the best checkpoint, and it will be replacing the best checkpoint with, if it continue training and find a model, a checkpoint is better than the one that is safe already, it will replace that best checkpoint. But then the other model will be, you will be seeing 2,000, 3,000, 4,000, 5,000, meaning it will be replacing it at each time step. It will be replacing it, even if it is better or worse, it will be replacing it. So that one that is better will be the best checkpoint, while this one that will be replaced will determine where your model training will start. So that maybe if you want to restart training, it will start, let's say, at 90,000 checkpoint, but maybe your best checkpoint is checkpoint 20. So if you are not saving that latest checkpoint, it will go back to 20 and then start training again. But if you have 2 checkpoints, one is best, meaning it's saving only the best, while the other one is saving at current time step or current checkpoint. So if you are starting training, it will start from 90,000 instead of 20,000. This is seeding. This is determining whether do you want to train, do you want to only evaluate, or do you want to predict. Evaluation is working on this validation. Training is working with this training data, and prediction is working with this test file. So at the end of the training, it used this predict to generate the translations that you have. So do you want to predict with generate? Yes. Do you want to override output directory? So it will check your output directory, which is this. If there are some files in there, it will override them, meaning it will replace them with, so there's first beginning of sentence token. In some architectures, you have to put in some of these parameters. So after setting this, you just say, run it. If there is a need to do editing, but if you don't have to edit, you just leave it as it is. Or if you want to train from, let's say, Hausa to English, you can rename this Hausa to English, and then your source language will be Hausa, your target language will be English, and your first beginning of sentence will be English, because you are training from English to Hausa. So, but if you don't need that, you can just leave it like this, you just run it. And this one will load all of the arguments that you pass into as training or as whatever parameter that you have. So this is the actual training. If you run this, it will start training a model. The problem I encountered with here, although it's not a problem, if you look at this, it took me about 34 minutes to finish training, which I don't think we have 34 minutes here, that we will be waiting for it to finish training. So it took 34 minutes to finish training. It took another 12 minutes to do evaluation, another 13 minutes to do prediction. So you see, all in all, it took us almost an hour to finish all of this. And I don't think we have that hour. So that's why before we start doing this, when I woke up in the morning, I trained a small model here. And if you see, this is the name of the model, M2M small, because it's the 418 parameter. There is a large, there is extra large, there was whatever. But the folder name does not matter. You can just name it M2M. Why we say small is, let's say you want to change and train big. Maybe you might say just big here so that it will not override this folder for you because you've already finished training inside the folder. So after it finished training and the rest, if you open this folder, you will find a lot of files. So there is all the results, there is config.json, there is evaluation results. And so this is PyTorch model.binary. If you hover on it, you will see that the model is about 1.81 gigabyte. So all of this will go into your memory if you are loading the model. So if you don't have a very large capacity GPU, your GPU will even fail, will tell you that I am out of memory. So, but Colab will allow you to work with this small model because it's small. You can have models with even 13 gig, 15 gig as size. So this is a small model. So, these are all the result.json will just show you the result after training. But I said there is something called blue or sacred blue as we import it there. So this is the figure here. So we have the evaluation blue, which is 12.4112. This is the performance of this model. And blue usually is measured from 0 to 100. So the larger your data set is and more qualitative and also more representative, the more your performance. If you have small data, you are more likely to have small performance. But although why I was stressing even more qualitative and more representative is sometimes all of this matters because what you really want is a model that you train that will not only perform very well on your training and your evaluation data, but it will perform on a data set that it has never seen. If you are, let's say, deploying and I want to translate something that I just create by myself, if that model is not able to translate that, so that your model is rubbish. So if you see, this is the performance of evaluation during training or on the evaluation data, evaluation testing, validation or development, whichever you call it. And this is the performance on the prediction blue, meaning on the test set, you have this. So you see the performance between these two are more or less similar. So now we have finished training. So now what do we want to do? We want to generate translation. We want to be the Google, the new Google. I have trained my model and I want to be using my model to be doing all of this translation exercise. So what I just need to do is I then create this for you. So creating this for you means you give in what is your source language, what is your target language, and where is your model directory. So your source language is English, meaning that the data set that I will be given will be in English language. The language that I want that data set to be translated into is Hausa language. And this is the model that I train, which is M2M small English to Hausa. So what I need to do is I need to upload this model into memory and the tokenizer for doing the tokenization, which we already told you what tokenization means. So we run this cell to do that for us. So you see it is uploading this model into memory. You see it is partial load, it is loading tensor. You see it here, it is loading from pre-trained. So it is working and loading the model for us. So before it finishes loading the model, you see our GPU is more or less small, so but it will work. So let's see this code. This code, as I said, you want to just write a form in which you ask the person, what sentence do you want to translate? So you just give it in there. So here, it takes the source sentence from this input box, and then it determines Have you provided the sentence? If you have provided the sentence, it generates the translation and display. If you did not provide any sentence, it will tell you that no input was provided. So I hope you understand. So we are waiting for this. So now the model has been loaded. The tokenizer has been loaded. You see it has finished running. So it took 1 minute, 5 seconds to load the model, 1 minute, 5 seconds. So if you see what I mean here. So here, let's assume we did not give anything, and then we run this cell. So you see, it will tell you no input was provided because I control this so that you don't want to just waste your time calling the model and working, and then the user have not imputed anything. So we take the sentence that we give in, we encode the sentence, and then we generate the translation. This is model.generate, meaning it take the tokenized sentence, which is the encoded sentence, and then it returns the translation, which is, then after return the translation, it's decode. Decode meaning it remove the tokenization. So if you are tokenizing word by word, then maybe afterwards you want them to be matched together. Or if you are using, let's say, byte pair encoding or sentence phase, as we've shown there, you remove the sentence phase tokenization. So here we can hide this code, sorry, hide code. So here, if you may suggest what sentence should we try? Give us an English sentence that we'll try our translator with. You can put in the sentence in the chat, or you can just dictate it for us. Let's just
Student loan has been approved, sir.
What?
Student loan has been approved.
Oh, so you guys, you like student loan. Student loan has been approved. So now let's run this to see how well our model will work. So an yarda da kuɗin ɗalibai. So this is the translation that was generated. The translation is an yarda da kuɗin ɗalibai. The translation is, I put it in the code. So you will see the translation is, and then it will take the translation and put it in here inside this code that I put. So I am the one that put all of this code and the rest. So it's just a formatted. But the actual translation that will be returned will be an yarda da kuɗin ɗalibai. So student loan has been approved. It translated to an yarda da kuɗin ɗalibai. So now you see an end-to-end, taking a model, fine-tuning it on your own data set that you have, and then testing the generation of translations after evaluating the model. So this is the end of this demonstration of how you take a notebook, you utilize that notebook to fine-tune your pre-trained language model. You can use different types of model that you have, and you evaluate it at the end of the day. So do we have any question on this demonstration before I respond to some of the questions inside the chat?
Yes, assalamu alaikum.
Wa alaikum salam wa rahmatullah. Who is speaking?
Yeah, it's Isaac Hassan.
Okay.
Yeah, regarding the translation, I saw you pass in 0 index. Does it return many translations?
Yes, so in our code here, if we take this, you see what we give in here is a single sentence. So meaning it will return translation of a single sentence. But we can give in many sentences. So saying student loan has been approved as a list. Student loan has been approved. I am going to school. This is my house. Many sentences. We can pass them directly into the translator, and it will return all of those sentences translated for us. And then we can then iterate over the translations that are returned. So why I said translation at index 0 is because we pass in only one sentence, so we are expected to get only one translation. If you pass in many sentences, you will get many translations that are returned. So in there, if you pass a list, you can view it either by printing the list or by maybe iterating over to pair the source sentence and then the target sentence to be printed. Or you can just paste the list that this is the translation. So you will see that there are many sentences because you pass in many sentences. But here we just pass in only one sentence, and it gives us this translation. So I hope this answered your question.
Yes, sir. Thank you, sir.
Okay. So do we have any question, or should I? Okay, let me see. There is a question from Nur. She said, my model is not performing well because the data set, the Hausa data set is not qualitative. However, I want to translate English data set to Hausa. Please, how do I go about it? So there are many ways to do this. You said your data set is not qualitative. How, if Nur will respond, please, how did you create this data set that was not qualitative? How did you create it? Did you use?
Good morning, Doctor.
Oh, yeah. Okay, good morning.
Yeah. Actually, I crawled the data set.
Oh, you
from
crawl?
BBC Hausa.
Okay, so you crawl, is it English or Hausa data set?
It's Hausa.
Oh, so you crawl Hausa data set from BBC Hausa.
Yes.
So how did you get the translation? Because you said your training data is not, your Hausa data set is not qualitative.
Yeah, I am working on a Hausa text summarization model.
Okay.
So I uploaded the data set into the model.
Okay.
So unfortunately, it contains a lot of duplicates.
Okay.
Yeah, so I think this is the reason why the model is underfitting.
Oh, so
Because
your Hausa data set have a lot of duplicates. Is that what you mean?
Yeah, exactly.
So what you do first, I think in the introduction to data pre-processing and the rest, what you are told usually is part of the pre-processing you do to data set is to remove duplicates. Even in translation, what you want to do is you want to have consistency in translation so that you are not confusing the model. So removing duplicate will ensure that your model know exactly what you want. So doing the duplication of the data set is the first pre-processing that is done on any data set that you want to work either in deep learning or in machine learning with. You want to duplicate one.
Yeah, I removed all the duplicates. I did all the pre-processing.
Okay.
Yeah, so the data set was about 1,500. So
Okay.
after the pre-processing, it reduced to about 600.
Okay.
And I'm working on deep learning. So I think this is the reason why the model is not performing well. So I have this English data set, and the English data set perform well on another English text summarization model.
Yeah.
So this is why I want to translate the English data set to Hausa, thinking that it will work well on my Hausa text summarization model. That's the idea I have.
Yeah. So this is a very good idea, but also it's a little bit risky also, because the performance of your text summarization model will now depend on two things. Ideally, if you create your data set from the scratch, it only depends on how big the data set is and how well created the data set is. But if you introduce translation into it, it also will take into cognizance how good is your translation model. If your translation model is generating a lot of rubbishes, your text summarization model will also inherit that rubbish. But then this is very simple. And I think if you follow this notebook, you want to do English to Hausa translation. So if you follow this notebook, you can train your model using this same notebook that I just presented. The only thing you do is in this generation of translation, you adapt the code so that it reads from wherever your English sentences are, and then it will do batch decoding or batch translation of the English sentence you have. And then you save your Hausa text. Or there are models also on Hugging Face maybe that will allow you to do that. Or also, if you like, you can use Google Translate to translate the file, because I think Google Translate can take a file as an input and then generate another file. Oh no, so it will generate on the screen the translation. So you can copy the translation and put it in another file and save it. So you can train your model by yourself, and if you use this notebook, it will train your model fine. You can use also Google Translate to generate the translations by yourself. And if you have anything that maybe I may help you, especially you doing the generating the translation, because that's the only thing that is left, adapting the translation code so that your model will be able to translate all of the text that you have. So if you have any challenge trying to implement that, you may ping me, and then I will set it for you working, inshallah. But this notebook, I think we'll share it with all of you guys. You can run it whenever you have the time. You can do generation of translation. You can play with it. It's just a playground for you to be trying. Yeah. So Dr. Saminu. Or do we have more questions?
Sorry, Doctor, I'm mute.
Okay.
Yeah, thank you so much. I don't know if you are done taking the questions, or because like
yeah, if they finish asking the question, then that will mean I'm done taking the question. But if they have any more questions, you can ask before we.
Okay, do we have anyone with question? If there is not, I think, yes, any question, please?
I think what we said during the presentation of the introduction to NLP was there are many problems that are associated with NLP and machine translation. Some of those problems include even how do you train a good model from a small data set, or how do you generate the data set? And I think Nur here example is a very good example or her situation is a very good example to explain. Sometimes the data set, you want to work on a specific task, but the data set is not available. So how do you work on that? So by that, you may try to create your own data set by yourself, either by using translation to translate the data because it's available but in another language, but you want it in your target language, let's say Hausa. So you can use it like, let's say, let me translate it to Hausa and then use it like that. Or there might be other ways that you can execute to generate your own data set. Or if you are buoyant enough, you can use your money to create the data set. Usually, if you use your money, you create something very good because you don't want to expend your money to create something that is bad. So, but creating something that is good also will help the community. If you finish using it, you can give other people also to use, either as part of application or as part of their research. So yeah, so these are some of the problems that you might find ideas on how to solve those problems, either towards creating data set, either towards using the small data set that you have to create very good models, either using fine-tuning or using it as a seed data to extract another data, let's say from a large data set. Or there are several ways that if you read the literature, you will understand and you will find about this more innovative ways to solve some of these challenges. So yes, Simon. You are mute.
Hello?
Yes, we can hear you.
Okay, too. Thank you so much, Doctor, for the presentation. And I think if we go through the notebook and we still have questions, I think, Doctor, you are free. We can all contact you for clarification, right? Maybe through the Telegram handle or...
Yeah, definitely. Definitely, yeah. Telegram will be fine. Although sometimes I take like 5 to 6 days even without going on Telegram. But yes, I will, if I see it, I will respond as soon as possible. But also, if you do not do anything that will change the code substantially, if you are asked not to change the code, if you do not change the code, it will run. If you change the code, maybe you change the code and then you don't know how to fix it. So the best thing to do is to take, because this notebook that will be shared with you will disable editing. So disable editing will mean that whenever you have the code, whenever you have the notebook, go to file and say save a copy in Drive. Save a copy in Drive, meaning you are creating your own that you will be working with it. You understand? Will disable editing. So if you open this notebook, you go to file, you save a copy in Drive. So that will mean that that is your own copy that you can play with. If you make any mistake on it, you can always revert back to this and save another copy in Drive. Do you understand? So yes. We don't want to enable editing so that other people will destroy the code and then we have to come back and start putting it together.
Exactly. Yeah. Exactly. Thank you so much, Doctor, for your time. And thank you to fellows for attending the session. And tomorrow, inshallah, we'll have another session at the same time where Dr. Ibrahim will discuss sentiment analysis. So please try to attend. Thank you so much. See you tomorrow.
Okay.
Bye-bye.
Assalamualaikum, Dr. Samino.
Walaikum assalam.
Yeah, mashallah. Sorry, is it also possible for us to upload this recording?
Yeah, it is. It is. Maybe just do it, please, because I'm busy working on student results. Please, you can assist in doing so.
Okay, no problem. I will. Yes, I will contact you. I will reach out to you later.
Yeah.
All right. Thank you very much.
Bye.